In this video, you're going to learn how engineering teams manage to scale their database layers from serving 50 users all the way up to 1 million users. Now, we're going to start with an example of a small startup managing their one database, and we're going to end up at an enterprise scale, speaking Instagram level application. If you're ready and you want to learn all of these interesting concepts, buckle up and let's get started. So this video is going to be a mix of theoretical and practical knowledge, meaning you can take the practical part and go implement it in your own application. But well, theory, we never leave the theory out. With that said, you're going to see that we have this arrow going on the left. It's going all the way to the bottom, and we have the number of operations on every level on the left side. Now, all the way up here, we have 0 to 50 operations per second, and 50, well, if I speculate this, it would be around 3K active users on your platform. So really a small startup that probably received some funding and is operating on a single database. Well, this will be the first level that we're gonna talk about. Now, every concept that you're gonna learn on this video is really applicable to any database of your choice, be it a relational database or a document-based database. Now, a lot of my users are actually using MongoDB. This is why I'm gonna be giving specific examples to MongoDB. But as I said, the theory that you learn here is applicable to your database as well. And by the way, MongoDB is sponsoring today's video, so thank you guys for that. And with that said, we're going to start with the very first level, which is the single database, small startup level. Now, on this level, it's important to note that it's all about iteration speed than perfect schemas. So meaning that as a startup, you really need to be shipping features and understanding your users and need to be fast, because a lot of startups die because they're too slow, instead of perfecting your schema and thinking about optimization at this level. What I want to say is that you should be doing the following. You should focus on vertical scaling. So instead of doing horizontal scaling, like literally adding more replicas of your database here, and in this case, we're not talking about MongoDB, but just generally adding more replicas of your database, like let's say read replicas, you can instead add more hardware into your database server. So you can have some extra storage here, you can have extra RAM, and eventually you can have more CPU power, so your database is a little bit faster. Now, the cool thing about MongoDB Atlas, and Atlas is basically the cloud solution of MongoDB, it's a managed cloud service, and it provides 3 nodes out of the box, so you actually don't have to worry about horizontal scaling. It's kind of enabled by default. This is why vertical scaling is already going to be the first thing that you should go for, even if you're using MongoDB. Because if we go to the list of tiers that you can choose from, even though I'm using M30, this is already quite big of a tier. We also have smaller tiers like M10 and M20. Guys, believe me, smaller tiers still can take you a long way, even if you're a startup. So you should be really comfortable with the cheapest one. And as I said, even the free tier is already good one from MongoDB Atlas. Now, with that said, we're going to focus on just the minimal indexing strategy, meaning making sure that you have indexing for your commonly used fields. So for example, I have one cluster in my MongoDB Atlas dashboard. I'm by the way logged in. First of all, gonna see that I have one primary database and 2 secondary databases, so 2 extra nodes, my replica set. And as you can see, it says 3 nodes. So in the Data Explorer, we're gonna see 4 collections that I have, and load data test. Where did this come from? I'm not sure. But anyways, I have one collection called orders, and it has many documents, and documents are basically the JSON objects, if you're not familiar. And what we're gonna see here is that we already have one index, and the ID is the default index that you're gonna have in every collection of yours. For example, ID is already indexed, but let's say if our application does filtering quite often by the user ID, you might consider adding the user ID as an index as well. Now, with that said, we also need to consider some proper data modeling. Data modeling is important in relational databases, meaning you need to really think about the design of your database before actually creating your tables. And it's also important in document-based databases. For example, when we store this document, we can see that we have an array of items, and it's going to have 2 items, 1 and 2. Now the question is it good to literally embed, or let's say hard code the items within as arrays within this document, which is responsible for an order. Or maybe it's better to store items as references and put their IDs here so that we can later reference these IDs from a different collection that, let's say, lives separately. What do you guys think? In any case, your database of choice probably has some best practices. And in case of MongoDB, there's also a dedicated page which tells you which linking method should you choose. Embedding, meaning kind of copying or putting the data as we saw in the first example, or referencing, meaning you would need to do a lookup here. Now, with that said, let's go to the second level, which is going to be 50 to 200 operations per second. In this case, some other things are becoming important. As your business is growing, you really need good credibility, meaning you should really focus on availability so that your application doesn't go down and you're still able to satisfy your users. And of course, in this case, of course, it's depending on the application that you have, but most of the applications are going to be concerned about the read scaling. So what are we talking about here? Now, this is actually the normal diagram for the MongoDB as instead of this one, because as we know, MongoDB has 3 nodes by default. So even this one should have looked like this one. So what do we have here? We have one primary database, and these are the secondary databases. And the primary one is going to be a write-read database, meaning this one accepts the write requests as well as the read requests from here. But these two guys are only responsible for returning data. So these are only responsible for read requests. And this is how we enable read scaling. So at this stage, replication solves availability and scalability, meaning every time the request comes here, read requests are going to be redirected to one of these guys. And every time the write happens, the write is going to end up in this guy. And then there's something called replication. Replication is basically the procedure of copying the data from the write database into the read databases, or let's say from the primary to secondaries. And as you understand, this is an asynchronous procedure, meaning there's going to be a lag. Now we're going to talk about this lag in a minute, but what should you do in order to enable read scaling and have more availability? Well, for read scaling, you need to enable replication within either on an app level routing or using a proxy. So on an app level routing, your Node.js or whatever service you're using has to decide which database it literally has to connect to. So you're going to have a kind of an, let's say, if statement. So if you're reading one of those 2 databases, if you're writing the data, your writes are going to end up in this database. Now, this is clunky. This is a lot of manual work. So you usually don't want to do that. Instead, you can use proxy. And depending on which database you're using, literally Google your database name and write proxy for read scaling, and you're going to get some answers. But MongoDB actually, or MongoDB Atlas, does this automatically. So you actually don't have to worry about that. The second thing you probably need to create is an replication user, the user that's responsible for streaming the data from the primary database to the read replicas like this, so that it has only the needed access and roles and is not a super user. Again, MongoDB Atlas takes care of that automatically. You also need to monitor the replication lag. So how much time does it take for the data to end up from the primary database in the secondary databases? Maybe your secondary databases, so these guys are located far away from the primary, so it might really affect your performance. You really need to monitor that, and I'm going to show you how to do that in a couple of minutes. And for high availability, meaning making sure that our database is available most of the time and is able to return the data, we need to make sure that we have a failover tooling. Now, if you're using something like a relational database, you can leverage the Kubernetes API for failover tooling, meaning if this database, for example, goes down, then within the 10 seconds, or by default in MongoDB, after 10 seconds, there's going to be a leader election process, meaning one of these guys, let's say maybe this one, is going to become a primary, okay? Then this one is going to stay as a secondary database. So if one of these guys is unreachable, then this one is marked as down, terminated, and a new read replica is going to become the primary one. And if you're not using MongoDB, even though MongoDB Atlas is going to do this automatically for you, you can use something like Kubernetes API to set this thing up. Or for example, if you're using Postgres, you can use Postgres config or modify it rather to enable this. Also keep in mind, as we talked about the replication lag here, so the time it takes to replicate the data into the read replicas, this is called eventual consistency, and I have a video on eventual consistency, so check it out. Basically, it means that the data that you're writing into this database is not synchronized into these ones right away. So let's say if you write the data here, and literally 1 microsecond later you try to read the same data, you might get the old data because it still didn't take its time to replicate it here. Now you can try to make your database strongly consistent. So strong consistency, it's basically the opposite of eventual consistency, and different databases, depending on what you're using, actually allow that. In MongoDB, you can try to make it more consistent. So you can change the write concerns to make sure that the write is successful once the majority of nodes have applied the changes, for example. But in any case, check the settings of the database that you're using. Simply Google your database name and strong consistency, and you're going to have some steps on how to enable that. Okay, now that we have enabled horizontal scaling, we need to max out our performance. So we need to think about indexing and caching, since our application is now really popular. So we're having something around 200 and 2000 operations per second. So this corresponds something like 300k active users, all right? Something around that, maybe 100k active users. In any case, what are we going to be concerned on at this level? So first of all, we need to really think about indexes. So we said we can create some simple indexes, and this was one of the examples. So let's say we have one index for ID, we have another index for user ID. Is this really sufficient? At this level, we should really start asking ourselves, or do we need to add more indexes? Well, to do that, we will actually have to start monitoring our database. Now, I have a simple application that's going to stress test our MongoDB cluster. So I come here and I will select popular application, let's say enterprise scale, and I'm going to start the stress test, and it's going to bombard our database with a lot of operations. And now that I waited a couple of minutes for my test to get a bit hotter, I'm going to switch to real-time observability to see what's happening within my cluster. Now I'm seeing some CPU data, and I'm seeing hottest collections, and I see that test messages, and well, actually most of them are having a lot of write operations. So my application is actually write heavy, and this gives me an indication that I can consider sharding in the future, all right? And now that the stress test is actually done, my CPU has gone back to 3. It was around 90 and 80, gives me an idea that I might consider some vertical scaling or even horizontal scaling to increase the nodes because the CPU was a bit too high. What I'm gonna do now is I'm gonna go to metrics. So here we're gonna see our primary node. We're gonna see 2 secondary ones, and each of them have different stats. So the primary one is apparently getting most of the commands here. And we also have some data for the replication tag, as I told before. So if I hover over this, obviously there's no replication tag lag in the primary node, but we do have some lag in the secondary ones. And this is completely normal. It really depends on your use case if you can tolerate this replication lag. In our case, it's 47 milliseconds. In my opinion, it's still okay. But if you want to improve that, of course, you can take further actions. And actually, MongoDB Atlas adds a lot of metrics that we can use here. Now, to further understand whether I need caching or adjusted indexing, I would come to Query Insights. And if I go down, I would see the shape of queries here, and I'm going to see the total execution time. And what I would also do is go to the query profiler here, and I would look at this graph to find the slowest operations that I had. So the count of operations that we can see is assigned to test.events collection is telling me that this is a very good candidate for caching. Now, MongoDB already has its built-in cache, that's using the RAM, but you can also opt in for a dedicated cache, something like Redis if you like. But this is already telling me that, of course, this was just a stress test, but if it was a real application, I would see that, hey, this collection is getting queried a lot. Now, if we sort by the meantime, we would see that actually shop.messages is our slowest operation, and it's a read operation. So maybe we need to add indexing if it does not exist yet. Also, what I'm gonna do here is come all the way here. I'm gonna say write operations. I'm going to select no index use to see where I might potentially add indexing. And let's say I select one of these guys, and we're gonna see what kind of an operation it was. So it was a write operation, and we inserted this document, but for some reason it was slow. So maybe we need to optimize our indexes further. So at this point, what we can do is, let's imagine this is our collection again. We can think about adding some compound and covering indexes. Well, compound indexes means that instead of adding multiple indexes to your collection, so let's say we have an ID index, we have an index for the total, we have an index for status. Instead, we can actually combine some of the properties and make an index out of 2 fields. This is much better than creating separate indexes for each fields, and also covering indexes. If we manage to create an index, for example, if our queries, or let's say most of the queries, are always asking for the ID, user ID, and the items, if we manage to create a covering index for 3 of these fields, and most of our requests are going to be like that, then this is going to be lightning fast with MongoDB. Also, partial indexes, for example, for some filtered items, let's say we make sure that we create an index for users up until 500. So this is going to be included, this is going to be included, this document is not going to be included, meaning we only create an index for half of our data. This is also something you might consider, or for example, some temporary indexes with a TTL. So after some time, these indexes are going to be deleted because the data is not important anymore or requested anymore. And last but not least, you can again consider caching as we saw. So if you have a high count of the request, then you can consider caching. If you have a high duration of the request, meaning you see some of the requests are slow, then you might go for re-indexing or redesigning your indexes. Now, with that said, we're going to come to the final boss of our database scaling, which is 2000 operations and plus. So what are we talking about here? So we're talking about scaling writes. So in the real-time overview, we saw that we have way too many writes compared to the reads. So this is an indicator that we can actually opt in for sharding. What do we mean by sharding? Let's try to understand. So replication protects availability while sharding enables a growth. So this is the last stage of our growth, and we optimized everything else that's possible. Now, sharding is going to enable us really fast reads and really fast writes. So what are we talking about here? Let's say we have this pattern already, and these are going to be living in 2 different shards. And now our replica sets are actually our shards that have primary and secondary within. Now the service is always going to request or contact this sharding router first, and then the sharding router is going to decide which shard the request is going to go. For example, if we are asking for a product name that starts with D, then the sharding router is going to decide that this request actually has to go to shard that holds the entries that start with A up until P, meaning this shard from P to Z is actually disregarded. What does it mean? It means we have less document scans, so the reads are going to be faster. We only need to scan the entries that are from A to P, and of course the writes are also going to be much faster. And we also have another node called config server, and config server basically holds the metadata for these shards, meaning it knows how our database is or our collection is sharded. Now, sharding in the MongoDB is done based on the collection, so it's on a collection level. Okay, so if you're using some other database, of course, you will have something similar, some similar architecture, but again, Google it and you will know how this is done. It's not that difficult, as long as you design and plan it properly. So when we talk about sharding, here are 2 important things. So you really need to pick a strategy for sharding and a shard key. So shard key is one of the properties of your collection. For example, for orders, what's going to be your shard key? Is it going to be the ID? Is it going to be the order ID? Or is it going to be the status? Now, this is a question. And here you need to think about the following types of sharding strategies. You can do it based on a range. So as we saw alphabetically here, from A to P, from P to Z, this is actually a range based. Or it can also be based on months of the year, let's say the years themselves, or even weeks and days. If your data is sequential, so it's based on the timestamps, then why not go for months, for example? Now, this is significantly going to improve your reads as well as writes. And we also have hash sharding. So there are going to be some random hashes. And the cool thing about here is that one of the goals of sharding is trying to evenly distribute the amount of data that lives here and that lives here. And with hashing, every time a new write is done, it's going to be evenly distributed in both directions, okay? Now, when you're reading the data, well, that's another question. It's not going to be as efficient as when you are writing. We also have compound shard keys. For example, you can create a shard based on a tenant ID or a user ID. This is also quite an often solution. In this case, I can also go just a tenant ID if I want to keep it simple. Last but not least, we also have zones. And depending on how international your application is, let's say if you have users from different continents, you can, for example, create one shard in Asia, create one shard in Europe, create one shard in South America, and you can make sure that you're placing these shards based on the user's location. So even the requests coming from the pool of users are going to be faster because the shard is living on the same continent that your users are requesting. And in MongoDB, it's super easy to do. So you actually have a map and you can select which kind of sharding you want. And by the way, I didn't show this before, but you can also change the number of nodes you want to have. Okay, so by default it's 3, but you can change it. And honestly, I'm not biased because MongoDB is the sponsor of the video, but you can also add read-only nodes, analytical nodes, and search nodes. This is so deep and this is super niche, and you can tweak so many things here. I really like it. Okay, another thing that you should be doing is enabling sharding router. And in case of MongoDB, it's Mongos. I hope I'm pronouncing it right. But in any case, as I said, your sharding router is going to be there for whichever database you're choosing. I'm pretty sure there's a way of configuring this sharding router. And hopefully you don't have to route your requests manually from your service itself. Things to keep in mind is, of course, you need to think about sharding up front. So even when you're on the startup level, even if you don't have that many users, you should be keeping this in mind. It actually applies to any database design. And if you are interested in that, I have a video on database design, and let me know if I should cover a sharding in one of the upcoming videos. Also, sharding adds extra complexity as always. And guys, if you learned something new in this video, I would be happy to see your comment. And of course, don't forget to subscribe. Check out our sponsor. It's the best way to support my channel. And I'm going to see you in the next one. Goodbye.